My name is Carolyn Sharp and I'm Miss Halverson's Period 6 Algebra 2 class. Today I will be teaching you how to use Descartes' rule to find roots of polynomial functions. What we're going to do first is find the number of positive roots by counting the sign changes in the given polynomial. So here is the given polynomial, f of x equals x to the third minus 5x squared minus 7x plus 51. So the number of sign changes is x to the third minus 5x squared is, yes, a sign change. But negative 5x squared minus 7x is not a sign change. So that's a no. And negative 7x plus 51 is a sign change. So the number of positive roots is 2. Next we will find the number of negative roots by substituting in negative 1 where x is and counting the number of sign changes. After figuring out what negative 1 is, your answer should be negative 1 minus 5 plus 7 plus 51. Now we count the number of sign changes. Negative 1 to negative 5 is not a sign change, but negative 5 to 7 is a sign change, and 7 to 51 is not. So the number of negative roots is 1. Now, if each positive root or negative root can be decreased by 2 without becoming a negative number, then that is another possibility in the number of roots. Now, our positive root is 2, and 2 can be subtracted by 2 to equal 0, which is not yet negative. So 2 or 0 is going to be our positive root. 1 is going to be our negative roots. Options for the roots. There. Okay.
Just kidding.
Shit and tits, man. Shit and tits. Okay.
You're going to redo it?
Yeah.
Okay.
Can you just...
Stop it?
Yeah. 1, we are only having 1 because 1 can't be divisible by, subtracted by. Fuck me! Okay. Now we're going to make a chart that has all the positive, negative, and imaginary numbers that we can find. So we're going to set this chart equal to the degree. And the degree is 3 because that is the highest exponent in our given polynomial. Under the plus column, we're going to use 2 or 0. And under the negative column, all we're going to put is 1 because 1 can't be subtracted by 2 without being a negative. Now see how we have 2 plus 1 equals 3, so we put a 0 else. But 0 plus 1 plus 2 equals 3. Yeah.
Stop there, yeah.
Okay. Because the negative column has no zeros in it, we're going to have numbers into our polynomial until we find an answer of 0. So the first negative number we're going to plug in is negative 2. So we're going to rewrite the problem. F of negative 2 equals negative 2 to the third minus 5 times negative 2 squared minus 7 times negative 2 plus 51. Okay, so negative 2 to the third is negative 8. And negative 2 squared is 4, and 4 times 5 is 20. Negative 7 times negative 2 is 14, so we're going to be adding 14, plus 51. Now, 8 minus 20 is plus a negative, so negative 28. 11, 7, 37. Negative 30, no, positive 37. Okay. Where am I going to start?
You said, and negative 14 plus 51 is, so just say.
And negative 14 plus 51 is 37. So negative 2 does not work because the answer is not 0. Now, since negative 2 doesn't work, we're going to try negative 3. So f of negative 3 equals negative 3 to the third minus 5 times negative 3 squared minus 7 times negative 3 plus 51. Negative 3 to the third is negative 27. Negative 3 times negative 3 is 9, and 9 times 5 is 45. Negative 7 times negative 3 is 21, and plus 51. Now we're going to add like terms, and it's easier to add negative 27 and 21, which equals negative 6, and negative 45 and 51, which is positive 6. And negative 6 plus positive 6 equals 0. So negative 3 is going to be our first root. Next, we're going to use synthetic division to find the value of the evaluated. Okay. So to start synthetic substitution division. So to start synthetic division, we're going to put a negative 3 in the corner, and we're going to write down all the constants. So 1, negative 5, negative 7, and 51. First things first, we're plus negative 3 is negative 8. And negative 8, a negative 7 is 17. Okay. 4 plus a negative 7, which is 17. And 17 times negative 3 is, is 17. And 17 times negative 3 is negative 51, which is 0. So our new problem is x squared minus 8x plus 17 equals 0. We're going to use the quadratic formula to find the remaining roots. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what we're going to do is we're going to substitute everything in. So for b, we're going to have negative 8, or a negative 8, plus or minus the square root of negative 8 squared minus 4 times 1 times 17 all over 2 times 1. Now we're going to simplify, and the simplified answer is 8 plus or minus the square root of 64 minus 68 all over 2. Now we're going to do 64 minus 68, which is negative 4. And we're going to have 8 plus or minus the square root of negative 4 over 2. Now we're going to separate this equation into 8 plus the square root of negative 4 over 2 and 8 minus the square root of negative 4 over 2. Now we're going to have 8 plus 2i because a negative number inside the radical becomes imaginary. And because 4 is a perfect square, we have 2 and over 2. And now since all of these are divisible by 2, we're going to simplify to 4 plus I. And that is one of our answers. Next, we're going to simplify 8 minus the square root of negative 4 over 2. And just like over here, the negative 4 becomes 2i. So it's going to be 8 minus...
because all the numbers are divisible by 2.
Yeah. And because all the numbers 4 minus I. And that is another problem. So our answers will be 4 plus I, 4 minus I, and negative 3. I hope I've helped you better understand Descartes' rule. Thank you for your time and have a nice day.